All right, this is trigonometry 4.1 homework and 4.2 homework, just going through it here just to make sure. So let's go with it here. 4.1 number 29. It states that you have to find the sine of negative 30 degrees, and it says use the fact that sine is an odd function. So what do you mean by odd function? Let's kind of remind ourselves what odd function is, because it's very important for you to understand where this is coming from so you see the connection. So odd function is this. Well, actually, let's take a look at all of them here. So if you have, this is the unit circle again. So this is theta turning up into quadrant 1 from the unit circle. And then you have a theta that's a negative theta that's turning down towards quadrant 4 off the unit circle. And if that's the case, then on top in quadrant 1 we have a positive x, positive y coordinate. And that corresponds to cosine of a positive theta and sine of a positive theta, since we're in quadrant 1. Alright, if you go on the bottom though, you notice this is going to be an x, positive x, but a negative y this time, because we're in the 4th quadrant. So notice as you go, let's see, towards the positive angle, or as a positive angle, counterclockwise, you're going to wind up with a positive x, positive y. If you go clockwise with a negative angle, you're going to wind up in x, negative y. So if that's the case, this corresponds to a cosine of a negative angle measurement and sine of a negative measurement. That's kind of what you really have to sort of see here. And so it's positive x corresponds to cosine negative theta, negative y corresponds to sine of negative theta. That's what we're looking for here. So let's talk about sine itself. So sine of a negative degree, this is how we prove it. Prove the fact that sine is a odd function, and then what does it mean for sine to be an odd function? Let's go for it. So sine of negative theta, if it's down here, there's sine of negative theta. That's the same thing as saying, or the coordinate of negative y. And this is kind of like the trick in our mind here. If that's negative y, notice it's in the exact same spot. So if this was this height here, and this was this height here, let me kind of draw it out. Maybe this will be even more helpful here. So right over here. So if this is negative y, that's the value of negative y, this would be the value of positive y. So if that's the case, then this is a little trick here, is to say, hey, you know what? If that's the negative y value, that's the same thing as just putting a negative in front of the positive y value. So it allows us to jump from quadrant 4 into quadrant 1. So if that's the case, the positive y coordinate is really just sine of positive theta. Alright, what does this proves that this is sine is an odd function. So now the question is, what in the world is an odd function? I'm kind of doing this backwards from the lecture that we did. An odd function says this. It says that if you have a negative value that's coming into the function, in order to get rid of the negative value inside the function, you have to put a negative outside the function, and then you can have your positive value going in. Just real quick here, let me draw this out and I'll erase it here. Just to give you a more fuller understanding of odd functions here. It is on the other video that we have. But x cubed, that's the easy example of an odd function. And what this says this, let me use 2 as an example. 2 times 2 times 2 is 8. So notice if I say f of 2, it'll give you 2 to the 3rd power, which is a positive 8. And then if I put in a negative 2, let's say this is a negative 2, what's going to happen here? Alright, what's going to happen here is you're going to get yourself a negative 2 times negative 2 times negative 2 gets you a negative 8. Okay, what an odd function says is this. If I wanted to compute the negative value, so f of negative x, it would be the same thing as me just putting a negative in front of the function itself and computing the positive value. So in this case, f of negative 2, which is negative 8, would be the same thing as, let me write it a different way here. It would be the same thing as just putting a negative in front of the positive value. And sure enough, f of negative 2 is negative 8. And negative f of 2 It would just be the negation of the positive value. Okay, how does that help us? Because when we do graphing later on, we'll learn that we don't know how to graph, or we don't have rules really developed for negative angles. So let me erase all this stuff here first. Erase. So all this says is sine of negative 30 degrees. If I want to get rid of this negative, I have to put it out in front. So negative sine of positive 30 degrees. Now positive 30 degrees we should know right away. That's pretty easy. That should be almost memorized to us here. So sine of 30 degrees is 1/2. So that means it's going to be a negative in front. So negative 1/2 is the answer to 29. Jump it. Let's jump to 31. So here, same exact issue here. Use the fact that sine is an odd function to simplify this. And so we take this negative, we drop it, but we have to put a negative on the outside if that's the case. So sine of 3 pi over 4, and if you look on your unit circle, positive 3 pi over 4 is 135 degrees. It's in quadrant 2. It has this ratio of negative root 2 over 2 and a positive root 2 over 2 on the unit circle. But don't forget the negative sign in front. It's a negative root 2 over 2. That's what we're looking at. Okay, it's just really quick and easy way to do this. It is a way that gets you to look at positive angles only, which allows you to use the unit circle that we have in the back of the book. That's one thing that helps. The second thing it helps is when we start graphing these guys, we are going to take the negative out of our trig functions. All right, just want to say where this is coming from. How do you know this is true? How do you know this is true? So if we do take the negative angle, just a quick more explanation here. If we do take the angle of negative 3 pi over 4, so that means it's going to go from here. It's going to swing back around. Here's my negative angle starting, right? And if I'm going to go negative 3 pi over 2, I'm going to wind up in quadrant 3. And in quadrant 3, here's my angle, which is about, yeah, it is negative 135 degrees. In quadrant 3, the coordinates are negative root 2 over 2 and another negative root 2 over 2. So you see that it kind of happens faster. If you can do the positive angle, it's going to happen a lot faster than trying to figure out, okay, I know now I go clockwise, now I got to turn this way, now I end up in quadrant 3. We're this way. You should recognize, hey, look, I'm only looking at my unit circle right here. Positive angles along my unit circle. I got it. I'm done. All right, turns out to be the same. Okay, this is just a quick example here. So when we're going to be graphing later on in 4.2, 4.3, we don't have rules for graphing this. And so what we do is we say, okay, hold on. We're gonna think of sine as an odd function. Odd function means I get to take this negative out of here as long as I put a negative in front. And that's what I'm going to actually graph in 4.2 and 4.3 and so on. I have rules for these that I've developed. All right, now we go on to 4.1, number 35. And this has to deal with, let me write it out just so we know what this is doing. This is to show that this is true. Well, whenever you're trying to see out of the blue to show if something is true, what you want to do is you want to just kind of play with it. This is make a diagram of the unit circle with an angle theta in quadrant 1 and its supplement in quadrant 2. Label the point on the terminal side, unit circle xy, point along the terminal side of the supplement, and use the diagram to show that that is true. So let's take a look at some numbers first. That's kind of what you want to do first here. See if this makes sense for numbers here. So here's my unit circle. And I need to show theta. That's in quadrant 1. So I'm going to just pick 30 degrees. Again, this is just to show. So theta is 30 degrees. 180 minus theta would be 180 minus 30 degrees would give you 150. And again, you don't have to copy this down for the homework. This is not for copying down for homework. This is for you to understand the homework. The next slide, I'm going to actually just do the homework itself. So 150 degrees would be right over here. This would be 150 degrees. And notice the little dashed lines that I set up. Notice on the dashed lines are saying that the y values are going to be exactly the same. They're the same level each time at 30 degrees or 150 degrees. Alright, so I got this one here. Let's say we go to 60 degrees. Let me erase this little guy since it's going to be on the next slide anyways. So let's say we jump to 60 degrees. At 60 degrees, 180 minus 60 degrees would be 120 degrees. If you do this on a unit circle, even in the back of the book, you're going to go over here and you're going to say to yourself, hey, you know what, if that's 60 degrees, that's 120 degrees, which is 60 degrees away from 120. I'm sorry, 60 degrees away from 180, sorry. So notice these guys are in the same spot. So I want you to kind of just sort of see this here. If this is x and y, it translates at 30 degrees. The x value is root 3 over 2, and the y value is 1/2. But if you translate it to quadrant 2, this turns out to be the negative of the x value, but the same y value. So this turns out to be, particularly for 150 degrees, it becomes a negative square root of 3 over 2, comma 1/2. And this is what they're trying to say, is notice the sine value or the y coordinates. So notice the y coordinate here and the y coordinate here. They are exactly the same, because if this is the y coordinate right here, it's true for both. It's the same for both. So let's look at the 60 degree angle. There's my y value. That's x, that's y. This would be negative x because they're in quadrant 2, but the same y value still remains. So particularly for 60 degrees, it's going to be 1/2 for cosine, square root of 3 over 2 for sine. In quadrant 2, what happens, it's the opposite for cosine, but it's the exact same height value for sine, because the height value is right here. That's the y value, and the y value is exactly the same. So the homework is saying this. Homework is saying, show that this is true according to a diagram, according to a picture. So here's what you got to do. Here's what you're copying for the homework. Is the unit circle. There you go. You're going to show the fact that you have a positive theta going this way. And you have a theta here. So the angle measurement here is really 180 degrees minus theta. That's what that little point there is. So I got my two values. This is going to be x comma y. In quadrant 2, it's going to be the same exact height for y. So this translates into the cosine value for x and the sine value for y. On the other side, you're going to write negative x comma y, which translates to cosine of 180 degrees minus theta. Again, that's corresponding to this one right here. And then sine of 180 degrees minus theta. That corresponds to that y value right there. Okay, so how do you prove that these are true? Well, we're going to start off. Let me maybe get my laser pointer here. There it is. We start off at, let's see. Let's start off with sine of 180 theta minus theta. 1 second, let me change up a little something here. So we start off here, and we're going to say that is the exact same thing as this y value right here. So this is the y value that is in quadrant 2. That's the one that we're looking at. That's this one right here. And then we ask ourselves, or we look at this and we see the diagram. Hey, you know what? That height is exactly the same height as this here. They're on the same exact height level. So that means this y value here corresponds exactly to the y value in quadrant 1. And in quadrant 1, that corresponds exactly to sine of theta. da 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 da. So we have proved it by these little equal signs right here. Boom, boom, boom. We have proved the fact that sine of 180 degrees minus theta is equal to sine of theta. Set it mathematically. We have proved in a diagram that the sine of the supplement is equal to the sine of the angle itself. So sine of the supplement equals sine of the angle itself. Alright, we have one more to do. This is problem 4.1, and let me kind of draw it out for this one here. I'm sorry, 4.2. 4.2, number 41. That's where we're at here. And so let me read it for you real quick here, then we go from there. Hopefully you have your book in front of you. So it says oscillating, no, sorry, just finding my place here. Alright, electric current, yeah, it's the EC, we're going to call it EC problem, the electric current problem. A current is alternating, varies in intensity with time. And so it says I represents the intensity of the current, T represents time, when the relationship between I and T are given. So I wish I gave you a little more information here, but here it is. In a alternating current, which is what comes out of the electric socket in your home, it's alternating current, and we're just barely getting into this here real quick here. It says I is measured in amps, T is measured in seconds. Find the maximum value of I, so we need to find max for I, and then we need to find how fast I goes through one complete cycle. Cool. All right, let's do it here. So the cycle piece right over here. Okay, let's jam with it here. So the question is this, and this is a kind of thinking question for you guys. What's the highest value that sine could be? What's the maximum value for sine? So whenever this is the maximum value that sine could ever go would be 1. So you have something that's multiplying 1. The highest it could be is 20 times 1, or 20. So in this case, depending on what kind of electric circuit you have, depending if it's trying to feed a computer or a toaster or a TV, the highest this guy can go would be, it would be 20 amps. Okay, cycle. So let's move on to the next one here. So the cycle is same thing as period. If you realize it, like, oh, that's right. Period determines the cycle. So as long as the cycle goes through once, the period is going to go through it again. And so how do we determine a period of sine? It's going to be that divided by b. And guess what? That right there is your b value. And so in this case, it's going to be 2 pi, right? Because the b value always multiplies your variable. So that's 120 pi. All right, pi's go away. 2 over 120. And we have 160. So it takes, let's see this. It's going to take 1/60th of a second to cycle through an electric circuit. And that's exactly what it is. That's why we have in America, we actually say we have a 60 hertz system. 60 hertz system is in electrical sockets. What happens is electricity goes back and forth. It alternates every 1/60th of a second. All right, so that should be it.